Welcome to our seminar. Today's explainer focuses on forensic data architecture and modeling hidden variables. A crucial question before analyzing corporate data. Is the environment truly chaotic or simply misunderstood? Our syllabus outlines 3 methodical steps: the baseline flaw, contextual collisions, and residual decomposition. Consider the streetlight effect, a corporate blind spot where leadership only optimizes what is easily measured. This introduces a type 3 error, assuming unexplained variance is random chaos due to primitive modeling. Look at the traditional baseline model. It wrongly assumes performance drivers act as completely independent forces. It forces relationships into rigid parallel lines, ignoring how real-world variables inevitably collide and interact. Let us examine our case study, the Iron Age KBQ data, to observe this baseline failure. A naive linear analysis assumes high-touch interactions, like grilling assistants, uniformly drive higher tip percentages. But what happens when environments shift and opposing real-world behaviors begin to cancel each other out? We must therefore inject a multi-context architecture, adding a multiplicative cross-product interaction term. This interaction weight transforms the geometry, shifting from a flat, rigid plane to a twisting surface. Consequently, the effective slope of your primary driver adapts directly to its surrounding environment. The single average assumption shatters when we contrast a quiet shift against a high-pressure pivot. During a quiet shift with low pressure, guests reward high-touch handling, creating a positive slope. Conversely, under high turnover pressure, hovering deeply irritates rushed guests, and the interaction weight turns negative. Let us methodically step through the metrics required to calculate the reclaimed noise percentage. The baseline sum of squared residuals captures the raw noise left over by a blind model. The interaction model SSR reveals the remaining error once we mathematically allow variables to collide. Finally, we calculate the precise percentage of raw noise reclaimed as pure, actionable signal. This massive variance reduction proves to leadership that unpredictable chaos was actually context-driven signal. I leave you with this. Is your environment truly chaotic, or are you just measuring mathematically blind?